Hello student, today we are going to study one of most important and most interesting topic in mechanics, that is center of mass. What is center of mass? How the position of center of mass is located in a point mass distribution system, in a continuous mass distribution system, and what is velocity of center of mass, acceleration of center of mass. All these things we are going to study in this lecture. After all, we will study collision theory, what is elastic collision, what is inelastic collision, and how oblique collision problems are solved. Let us see one by one. Okay, so what is center of mass? Dear students, center of mass of a point mass distribution system or a continuous mass distribution system or a point mass distribution system is a point located either inside or outside the body at which complete mass of the system is supposed to be concentrated. In physical sense, it is not necessary that some or complete mass is present at this point. And vector sum of moment of masses about this point remains equal to 0. Vector sum of moment of masses about this point remains equal to 0. This center mass represents the translational motion of a body about the point center mass. We can imagine the translational motion of a body. Okay, so let's start finding coordinate of center of mass, how center of mass is calculated. Let's see. So dear student, today we will study finding position of center of mass for two particle system. Finding position of center of mass of two particle system. Let us see. These are 2 point masses M1 and M2. Let us assume separation between them is L. Let us assume this point P is the center of mass of this system. This is located at distance x1 here and x2 here. x1 plus x2 equal to L. So coordinate of M1 with respect to P. Let us assume coordinate of P is 0, 0. So coordinate of M1 is x1 minus x1 0 and coordinate of M2 is x2 0. Okay. Now the fundamental definition of center of mass about center of mass, moment of masses, vector sum of moment of masses remains equal to 0. That we are applying here. Okay. So dear student, M1 x1 vector plus m2 x2 vector. This is equal to 0. So we are getting m1 x1 minus I cap plus m2 x2 I cap equal to 0. So we can write x1 equal to m2 x2. We can write m2 into L minus x1. And now we can see m1 plus m2 into x1 equal to m2 into L. So dear student, now x1 equal to m2L upon m1 plus m2. And in a very similar way, if we want to write x2, x2 is what? L minus x1. So this is m1L upon m1 plus m2. If m1 equal to m2, then what happens? If m1 equal to m2, then center of mass x1 equal to x2 will be equal to L by 2. Okay. So dear student, this is very important point. In case of symmetrical mass distribution system, always remember, in case of symmetrical mass distribution system, the center of mass is located at its center of symmetry. Okay. In case of symmetrical mass distribution system, the center of mass is located at its center of symmetry. Okay. This funda will be utilized at many places in solving the problem of center of mass. Okay. So let's start solving position of center of mass for a point mass distribution system. Position of center of mass for point mass distribution system. Dear student, we will locate position of center of mass for point mass distribution system. Let us see. If n point masses are there, m1, m2, m3 and mn, and this is origin, reference point. This O is a reference point. Let us assume the position vector of m1, m2, m3 whose coordinate are x1, y1, z1, x2, y2, z2, x3, y3, z3 and xn, yn, zn from reference point are r1, r2, r3 and rn respectively. Dear student, r1, r2, r3 and rn are the position vector of point masses m1, m2, m3 and mn. Okay. And let us assume this point P is the center of mass of the system whose coordinate is xcm, ycm and zcm, and position vector of center of mass with respect to reference point O is rcm. Okay. Now let us join center of mass with point m1, m2, m3 and mn. let's start. Let us assume this is r1 dash vector, this is r2 dash vector, this is r3 dash vector, and this is rn dash vector. Okay. Now the basic key concept of writing the center of mass is about center of mass. Vector sum of moment of masses remains equal to 0. So we will be writing equation for center of mass, and we are applying equation in this triangle O, P, and suppose this point is A, this point is B, this point is C, and this point is D. Now we are visualizing triangle OPA. What we are getting? RCM plus R1 dash vector equal to R1 vector. Okay. RCM vector plus R1 dash vector equal to R1 vector. So we can get R1 dash vector equal to R1 vector minus RCM vector. This is equation 1. Okay. In a very similar way, we can find other equations also, like R2 dash vector will be equal to R2 vector minus RCM vector, and Rn vector will be equal to Rn minus RCM vector. So dear student, we will be writing equation for center of mass. Okay. So the general equation about center of mass we are writing here: M1 R1 dash vector plus M2 R2 dash vector plus Mn Rn dash vector equal to 0. This is the general equation of center of mass, because about center of mass, vector sum of moment of masses remains equal to 0. Okay. Now we are substituting the value of R1 dash, R2 dash, and Rn dash vector. Okay. So dear student, this is M1 R1 minus RCM, as we have calculated earlier. Okay. In a very similar way, this is M2 R2 minus RCM vector plus dot dot plus Mn Rn minus RCM vector equal to 0. If we solve this equation, we will find RCM vector equal to what? This is M1 R1 vector plus M2 R2 vector plus dot dot Mn Rn vector divided by M1 plus M2 plus dot dot plus Mn, which we can write as summation Mi Ri, the range of I from 1 to n, divided by summation of Mi I equal to 1 to n. Dear student, this is the general equation for calculating position of center of mass. See here, what is R1, R2, R3, Rn? R1, R2, R3 and Rn are the position vector of various point masses with respect to reference point. R1, R2, R3, Rn are the position vector of various point masses with respect to reference point. And RCM vector is the position vector of center of mass with respect to reference point. Okay. Remember, center of mass of system do not change on change of position. Okay. Change of reference point, center of mass, wherever center of mass will be there, center of mass will be there. Okay. Now, if we are interested in writing the x coordinate, y coordinate, and z coordinate, we can write a R1 vector equal to what? X1 ik plus y1 jk plus z1 kk. R2 vector equal to x2 ik plus y2 jk plus z2 kk. And Rn vector will be equal to xn ik plus yn jk plus zn kk. Okay. And in a very similar way, RCM vector equal to xcm ik plus ycm jk plus zcm kk. In that way, we can find the position vector of center of mass, x coordinate, y coordinate, and z coordinate. Okay. Very simple. Now see. So dear student, now xcm will be what? The x coordinate of center of mass will be m1 x1 vector plus m2 x2 vector plus dot dot mn xn vector divided by m1 plus m2 plus mn equal to summation mi xi I ranging from 1 to n divided by summation mi I ranging from 1 to n. This is XCM. And now YCM in a similar way. M1 Y1 vector plus M2 Y2 vector plus dot dot Mn Yn vector divided by M1 plus M2 plus dot dot plus Mn. This is YCM. And in a very similar way, this is ZCM. This is M1 Z1 plus M2 Z2 plus Mn Zn divided by M1 plus M2 plus Mn. Dear student, this is ZCM. And position vector of center of mass is XCM IK plus YCM JK plus ZCM KK. Okay. Now, let's start solving the position of center of mass. Okay. Figure shows a point mass distribution system on a straight line. This is 2 kg mass, this is 4 kg mass, and this is 3 kg mass. The 2 kg mass is located at a distance of 2 meter. 4 kg mass is located at a distance of 4 meter. And 3 kg mass is located at a distance of 6 meter. From this reference point O, we have to find position of center mass, x coordinate of center mass. Very simple. In this question, m1 x1 all are positive. Okay, m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. After solving this, this will be 4, this is 16, and this is 18, this is 9. So this will give us 16 plus 4, 20, this is 38 upon 9. So this is the answer. This XCM is, so dear student, XCM is what? 38 upon 9 meter. This is the answer for the position of center of mass. Okay. Let's see one more question. Figure shows a equilateral triangle ABC of side length L. Let us assume a point mass M, 2M and 3M are kept at corner ABC in XY plane. Okay, in XY plane. This is also very important, that in which plane the system is lying. Now we have to determine position of center of mass of this point mass distribution system about reference point B. About reference point B. Now what we will be doing? We will be taking coordinate of reference point as 0, 0. Okay. find position of center of mass with respect to point B. Now, dear student, we are preparing a table with respect to reference point B. Okay. This is mass 2m, this is mass m, and this is mass 3m. We will be writing x, y, and z coordinate. Okay. m, 2m, and 3m. Write the x and y coordinate with respect to reference point of various point masses. Dear student, what you are observing? The coordinate of x and y coordinate of point mass m with respect to reference point B is this is L by 2 and this is L square minus L square upon 2. So this is 3L square under root 3 L root 3 upon 2. So the x coordinate is L by 2, y coordinate is L root 3 upon 2. 2m 0 0 and 3m is L 0. Now it's very simple. Once we find the coordinate, in case if coordinate are coming in minus, you have to write minus also. Okay. So dear student, what is XCM? XCM is m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3 means 3m plus 2m plus m, that is 6m. So dear student, take ml common. This is 1 upon 2 plus 3 divided by 6m. Now mm get cancelled. This will be 1 plus 6, that is 7. 7 upon 2. 7L upon 2. In a very similar way, we can find YCM also. What is YCM? M1 Y1 plus M2 Y2, that is 0. M3 Y3, that is also 0. Divided by M1 plus M2 plus M3, this is 6M. So dear student, the final answer of YCM is MM got cancelled. This is L root 3 upon 12. This is YCM. So the position of center of mass is 7L by 2, 7L by 12 and L root 3 upon 12. This is the position of center of mass. Position coordinate of center of mass with respect to reference point B, with respect to reference point B. Okay, this is the answer. Now, if we are interested in finding the velocity and acceleration of center of mass, that also we can easily find. Differentiate the equation of position vector. Okay, then we can find velocity of center of mass equal to what? M1 V1 vector, M2 V2 vector plus Mn Vn vector divided by M1 plus M2 plus dot dot Mn. And in a very similar way, we can write the equation for acceleration of center of mass also. This is M1 A1 plus M2 A2 plus Mn An divided by M1 plus M2 plus dot dot M plus Mn. This is the acceleration of center of mass. Dear student, this equation is very important. This is total mass. When total mass is multiplied by acceleration of center of mass, this will be force on center of mass. And what is equation of Newton's second law of force equal to rate of change of momentum? Okay, so one very important relation I am telling you. The force on center of mass equal to d by dt momentum of center of mass. If force on center of mass in particular direction is 0, then acceleration of center of mass will be 0, and dear student, velocity of center of mass will be constant. Constant means what? Either it will be 0 or it will be constant. So remember, very important point. When external force do not act on a system, then position of center of mass remains unchanged in that direction. When external force acting on a body is 0, then position of center of mass in that direction remains equal to 0. This funda will be utilized at many places in solving the problem. If initially center of mass is at rest, then final center of mass will also be at rest. Okay, so this funda will be utilized at many places. So dear student, in the next lecture we will be looking for center of mass for continuous mass distribution system and finding position of center of mass for cavity. Okay, thank you very much.